This video is for the velocity as a vector calculations. We've already shown you how to get the measurement. So the angle I measured would go here, the time I measured would go here, the horizontal distance, the x sub x, would go here, and then I should be able to find the velocity. If you know the time and you know the distance, the velocity is not changing, so you should know how to calculate the velocity. Every calculation you do needs to be shown in your book, because it's not like we're doing the same thing over and over. You're going to do each of these once. Then I have my y distance, which we've measured, would go here. Then I use the same time. It took the same amount of time to go in the x direction as it did the y direction, so then I calculate my y velocity. Here's my x distance, that's the diagonal distance, goes here. Then I calculate my velocity in the diagonal distance, the straight line velocity. Then I'm going to compare these two items, my x velocity plus squared plus my y velocity squared. Calculate that. I calculate my d velocity squared, my diagonal velocity, and I find the percentage difference between those two. Then I take my diagonal velocity times the sine of theta goes here, and then I compare that. The instructions tell you what to compare to, but I'm going to compare that to the sine is my y. And I didn't make you rewrite it again. So I'm going to compare my y velocity to VD sine of theta. I'll compare my x velocity right here to my VD cosine of theta. Find the percentage difference. Then I take the tangent of my angle and I take my y velocity over my x velocity and I do the percentage difference of those. And when you've done that and you've shown all your work, before you go to the next part of the lab, have me check this part off to make sure we've got it right so you don't have to redo it. Good luck.